Hello. Hello, good morning. Good morning. Can you hear me? Can you hear me, Jonathan?
Yes.
All right. Good morning. How are you?
Good.
Glad you could make it. Good morning, Valentina. All right. Give me just a moment while I pull up the homework. All right. I posted this yesterday afternoon, so I'm not sure if you had a chance to see it or not. All right. So this is about solving inequalities. Quadratic inequalities. Have you guys have a chance to look at this yet? Maybe let's take a look at the first one. Okay, on this first problem, the first thing that you want to do is make sure that one side is 0. And so we've already see that on the number 1, it is equal to 0. And so the next step would be, since it's a quadratic, we want to factor it. So in this case, I'm looking for two numbers that multiply to 3 and that combine to 4. And so that would be 3 and 1. And they would both be positive. And then this is less than or equal to 0. So x plus 1, what makes that 0, if I could, you can set it equal to 0 and solve for x, but this is a pretty simple sort of factor. So I just say, well, what number would I put in for x that when added to 1 is a 0? So this would be x equals -1. And likewise with x plus 3, this would be x equals -3. So then the next step would be to graph these on a number line. So here's -3, and here's -1. And since it can be equal at that point, then we use a closed dot. And so we put a closed dot at 3 and a closed dot at -1. And then we make a sign chart. We say like -3, that's our, like, we assume that to be our 0, so that everything to the left of that would be negative. So we put a negative here, and everything to the right would be positive. So I'm just considering the interval between -3 and a -1, and then positive. Let me erase that a little bit. So this would be positive. And then -1, that's then our 0, and so everything to the left of it would be negative, and to the right, positive. And then we multiply out the signs. Negative times negative is positive. Negative times positive is negative, and positive times positive is positive. And so going over here to the idea that this quadratic is less than or equal to 0, less than 0 means that it's negative. And so this is the one that we're looking for our solution. And so we shade in between there, indicating that that's where our solution is. And then in terms of an interval, we would write a bracket at -3. The bracket is like the closed dot over here on -3. It means it can be equal to -3. Then we put comma, -1, and then again we have a bracket. Do any of you have any questions about that? Okay. Let's do number 2. So with number 2, we don't have 0 on the right-hand side. We have 27x. And so I'm going to subtract 27x from both sides. And that would give me 5x squared minus 27x plus 10 is greater than or equal to 0. And then we have to factor this. We need to remember that when you have as your leading coefficient something other than 1, like 5 in this case, that we take 5 times 10, which is 50, and we put that over -27, And then we say, what two numbers multiply to give you 50 that would combine to be negative 27? So I'd like one of you to answer that. What two numbers multiply to give you 50 that combine to give you negative 27? Victoria, do you have an answer for that?
No.
Uh,
Jonathan, you got it?
I think so. Wouldn't it be negative 25 with negative 2?
Negative 25 and negative 2. Let's see. Negative 2 times a negative 25. Negative times negative is positive. That'd be positive 50. And then negative 2 plus negative 25 would be negative 27. I think you've got it. So then we put it in the box. So we put 5x squared up here. We put plus 10 down in the bottom right. And then in these boxes here, we put negative 27x, but we use these two numbers to do so. So we put, what did I do? Oops, hit something. Okay, so negative 25x and negative 2x. And again, it doesn't matter where you put these. If you put it down, negative 25x down here, you just switch where the factors are up here. So over here, I see what's the greatest common factor between 5x squared and minus 25x, and that would be 5x. 5x times x would give me the 5x squared, and 5x times negative 5 would give me the negative 25x. And then x times minus 2 would be negative 2x, and negative 2 times negative 5 would be positive 10. So it works all the way around. So our factors then are 5x minus 2 times x minus 5, and these are greater than or equal to 0. Here's an example where it's nice to actually set each of them equal to 0. So say 5x minus 2 equals 0, or x minus 5 equals 0. And 5x minus 2, if I add 2 to both sides, that gives me 5x equals 2, and then divide both sides by 5, x equals 2/5. And over here, x minus 5, adding 5 to both sides gives me x equals 5. So on my number line here, I'm going to put 0 just as a point of reference. 1, 2, 3, 4. Oops, I'm making these too big. 1, 2, 3, 4, 5. So here's 5. And 2/5 is between 0 and 1. And it's right about here. And I'm putting closed dots again because of the equal, less than, this is greater than or equal to. But greater than or equal to 0 would be positive. And so we make our sign array again at 2/5. to the left would be negative, to the right, positive, and positive. And then with 5 is the 0 mark, the central mark, negative to the left for each of those, and then positive to the right. Then a negative times a negative is positive. Negative times positive is negative, and positive times positive is positive. And this time we're looking for the intervals that is positive because it's greater than or equal to 0. And so instead of shading in here where it's negative, we shade out here. Draw a little arrow on the end because it continues. And then over here as well where it's positive. And so in our interval notation, this time the leftmost number, there is no leftmost number, so it would go clear to negative infinity. We can't approach negative infinity, so we use a parenthesis rather than a bracket. But on the right-hand side, we put 2/5. And we use a bracket there at 2/5 because it can be equal to 2/5. And then we use, because we're going to have two intervals, so we use a union to join those two intervals. And then 5 with a bracket, and it goes off till positive infinity, again with a parenthesis. So let me ask you a question here. What, on number 4, what would be your first step to solving this problem? Can I ask that to Valentina?
Maybe pass the 12 to positive.
Yeah, you'd add 12 to both sides to get the right-hand side as 0, and then you'd have x squared plus 7x plus 12. What would you do next?
Find two numbers that multiply give me 12 and adding or subtracting 7.
That's exactly right. So you're starting the process of what's called factoring. You're going to factor those two numbers, or that polynomial. Once you've found the two factors, you're going to set each of them equal to 0. You're going to graph them on the number line and make your sign chart, trying to decide which two numbers are there, and then where the intervals or interval over which that thing is less than or equal to 0. All right. You guys want to go over another one?
Yes.
Which one would you like to go over, Valentina?
Maybe number 11.
Number 11. Let's look at number 11. Okay, so we've got s squared. Thank you, Valentina. S squared minus 13s plus 42, and this is less than 0. So our first, because we already have 0 on the right, we don't need to worry about that. So our first step then is to say, what would this thing look like factored? So I'm going to put s in each of these parentheses, and then I'm saying what two numbers would multiply to 42 and add to negative 13. So I know that both numbers are going to be negative, and see what numbers multiply to 42. The numbers that come to mind would be 6 and 7, and 6 plus 7 is 13, so I'm going to say it's negative 6 and -7. And then these are less than 0. S minus 6 would give us S equals 6, because 6 minus 6 is 0. Or S equals 7, because 7 minus 7 equals 0. Then I've got these two numbers. Before I go over there and graph them, I'm going to just make note that less than 0 means that these are negative numbers. We're going to find where is this thing negative. So 6 and 7. Again, just for point of reference, I'm going to put 0 here. Wait, here, this is a little bit different because here it's strictly less than. And so I can't be exactly equal to 6. For this, we're going to use an open dot and an open dot at 7 as well. I'm going to label these 6 and 7. And then to the left of 6, I'm going to make it negative and positive to the right. And then at 7, I'm going to make it negative to the left and positive to the right. And then I get my multiply my signs out. Negative times negative is positive. Negative times positive is negative, and positive times positive is positive. And so it's negative in between 6 and 7, and so we shade in between them. And that would be where our solution to this inequality would be. And so in our interval notation, this time instead of a bracket at 6, we're going to use a parenthesis because it cannot equal 6. And then it goes all the way over to 7. And again, does not equal 7, so we put a parenthesis rather than a bracket.
How do we know we have to use a parenthesis or a bracket?
That's a good question. Let me answer that question just to the side here real quick. X is less than 3. Looks like this. We use an open circle at 3. And then because it's less than, it goes to the left. And if we're writing, that's what it looks like in terms of the graph. If we're looking at what it looks like in interval notation, this goes all the way to negative infinity. But since negative infinity is not something you can actually arrive at, it's not a number it can be equal to, we use a parenthesis. And then and because it's x less than 3, it's not less than or equal to 3, it's less than 3. We put 3 over here and we use, again, a parenthesis. If I had x less than or equal to 3, this time instead of a open circle at 3, we use a closed circle at 3 to show that it can be equal to 3. And then we still move off to the left. And because it goes clear off to the left, on the left we put negative infinity, and on the right we put 3, but this time we use a bracket to show that it can be equal to 3. Over here on the first example, when it was just x less than 3, It could be 2.9, it could be 2.99, it could be 2.999, but it cannot be 3 because it has to be less than 3. And so that's when we use the open circle in the graph and the parenthesis. Over here, it can be equal 3. It says x is less than or equal to 3. And so that's why we use the closed dot, and we also use the bracket at 3. Let's say we had x less than 2, or x is greater than 2, less than or equal to 4. In this case, we're sort of combining our symbols a little bit. And so if I had 2 here and 4 here, at 4 I'd use a filled-in dot, and at 2 I'd use an open circle. And then I'd fill in the spaces in between. And for the interval notation, I would show a parenthesis at 2, and at 4, a bracket. And so what this means in interval notation is it means that it includes all of the values between 2 and 4, not including 2 because of the parenthesis, but including 4 because of the bracket.
So basically, we use the brackets when it's greater or less or equal than some number.
Right, but it has to have the equals.
And and the parentheses when it's not that exactly number, just like it's greater or less than that number.
Right. Yes, if I if I put, let's say x is greater than 2. Let's say greater than or equal to 2. Then that would be, it would start at 2 with a bracket. And because it's greater than, it goes off to the right until it reaches positive infinity, which it never will. And that's why we put a parenthesis at infinity always, or negative infinity. Does that clear things up a little bit?
Yes, thank you.
You're welcome. I think I could go through one more with you. Would you like to choose that for us, Jonathan?
Number 6.
Number 6. All righty. So number 6 has got 4x squared is less than 9. So we want to rewrite this as 4x squared minus 9, subtracting 9 from both sides, is less than 0. And then we want to factor the left-hand side. Now this is a little bit different. It just has the two terms, and if you recall, 4x squared is 2x, the quantity, squared, and 9 is 3 squared, and they're being subtracted. And so the factoring strategy we would use here is called the difference of squares. So I would write 2x and then 3 and then 1 is plus and 1 is minus. And then these are both equal to 0. So then I set each of these equal to 0. 2x plus 3 equals 0. Or 2x minus 3 equals 0. 2x equals -3, or x equals -3, -3 halves. Over here, 2x equals, adding 3 to both sides gives us 3, and then dividing by 2, x equals 3 divided by 2, or 3 halves. So -3 halves and +3 halves. Again, just making note here that less than 0 would mean that this is negative. And so we come over here to our number line. Three halves is 1.5, so it's between 1 and 2, and -3 halves would be between -1 and -2. So I'm going to graph those. And then I'm going to graph 3 halves. And I'm going to use an open circle. And over here, -3 halves, again, an open circle. Then I'm going to make my sign chart. And I'm going to consider -3 halves. To the left would be negative, and then positive, positive. And then 3 halves, that's the center point. Then to the left of that would be negative in each of those intervals, and then positive. And then I'm going to multiply them out. Negative times negative is positive. Negative times positive would be negative. And positive times positive would be positive. And because we're looking for negative, we're looking for the space, the interval between those two. So we can fill that in. And so then over here we write, for our interval notation, -3 halves. And it goes all the way over to +3 halves. And we're using parentheses because they cannot be equal at those endpoints. They can go right up to them. This is, if -3 halves is the same as -1.5, it can go to -1.4, -1.49, but it can't get to -1.5. And likewise on the other side. You guys have any questions about this? Victoria, do you have any questions?
No.
You're good? Valentina?
No, I'm okay.
Jonathan, how about you?
I'm good.
All right. I'm going to close the meeting, then I'll let you guys practice some of those, the others that I didn't do on your own. But thank you all for coming. I am going to put a recording of this on the website a little bit later when I'm able to process it, so that people that weren't able to attend can still watch. All right. All right. Hey, you all have, sorry? You all have a wonderful rest of your day, and we'll have another meeting. Today's Tuesday. We'll have another meeting on Thursday. And I'll hope to see you then. Take care.
You too.